Thank you, Jaspreet. Good afternoon, ladies and gentlemen. I know we are already late by 1 hour on the session, so we'll see how fast we can make up the time for this. So I'm sure all of you who are sitting here are here to listen to this part, and this is what you all want to do this. So there are three things which, you know, the spreadsheet can't do, but ArcGIS does, and you have been doing this where things happen, right? That's what the GIS systems like ArcGIS do for you. Why things happen is something, again, which you have to do and find it out. And ultimately, this is the crux of this, what action to take. If you are not able to do this, then I think the GIS stops there. GIS, actually, we can't go forward from them. So that's being the crux. You know, we at Esri are very much thinking about how do we go forward. And you could have seen from the morning the various sessions we talked about advancements in technology. So this particular part of the digital transformation drives us. You know, one of these are the 4 adopters. The first is the cloud adoption. And you know, most of the Esri products are now on cloud. Very few may be there which are not yet on the cloud, but about 70 to 80% of the products are available on the cloud now. And now we are getting into a lot of third-party platform integrations. In the morning, it was again conveyed about like having R, the powerful statistical program, which has a very tight integration with it. We have multiple other partner products which are getting integrated into this to give our users the maximum benefit. The IoT, you would have seen that. We will be seeing some of them again today in the afternoon. And all of these are combined, and they are now moving into augmented humanity. It's not augmented reality, it's augmented humanity, and that's where we are going in. So all of this crux actually helps us. These are some of those emerging technology trends in 2017. The more you adopt the technology, the systems are getting moved towards that. So this is where the ArcGIS, being the mapping and the analytics platform, this is where we integrate all different kinds of data sets, from vectors to rasters to business to big data, all of them which have been integrated. And in addition, getting supported for the real-time sensors and other observational data, we are actually giving a lot of context to the data what you are doing in. So first to that, you have just now seen one of the demonstration of drone to map. To many of the users who are not know what this product actually does, drone to map is an app on our portal, and the AJL in the ArcGIS online platform. You need to have either of them where it can be done. It can help you getting orthomosaics, DSMs, DTMs. It can even generate your LAS files, and also you can design your own workflows for that. So if you can look in this, the drone mapping workflows, so some of the drone manufacturers, they do both of the tasking and collection job, which they do it. And that's where you could have seen Video Sky being specialized in that. And we, on the other part, are on the PED, where we do the processing, exploitation, and dissemination. Actually, it's more which I feel the dissemination capability of Esri being very powerful. With a few minutes of processing, you're able to see this on a simple browser in form of a scene, web scene. That's the crux and the strength of this product, where it drives into. So you can see there are some of those examples of how the 2D mapping routing is being planned in about. You can see that's how the drone flies for that. Similarly, you can do for the Nadir, where you do a Nadir mapping for that. And then finally for the inspection workflow. So based on your work, you can design your process and the workflow for that. And this is where I was telling you, you can immediately share this process. Once the process is done, these chain layers can go into your enterprise and can be available for enterprise-wide. And the user requires just a browser to visualize this and analyze that. So let's see the first demonstration towards this. What's the drone to map? What's the capability of all this? Partha, can you help us with that?
Yeah, sure. Yeah. So thank you, Krishna. This is drone to map. My colleague Jaspreet already demonstrated the output of the product. But here I would like to, what is the background work we are doing using drone to map? Here you can see, for example, this is the area of interest. We are going to fly the drone. Drone has been flown. This is the path of the drone flying. And these are the location from where the photograph has been captured. Now, if I click anywhere, any particular dot, we will be able to see the photograph itself. For example, if I go to the next dot, we will get the next photograph and so on. And you can see ample overlapping portions are there. The photographs has been captured in such a way that overlapping should be there. So that overlapping software will consider as the stereo pair and digital elevation model will be created. Let's see what are the properties of the image. These are the JPEG photographs, and all photographs are tagged with latitude, longitudes and altitudes. Proper projection has been used here, and what are the things can be done from drone to map. First thing is that we can generate the ortho-rectified ortho-mosaic image. As you have seen, all photographs are oblique photograph, but our requirement is complete nadir view. Ortho-rectification is required for GIS mapping. So ortho-rectification, ortho-rectified map, it will generate digital surface model, digital elevation model will be generated. At the same time, from the stereo pair, it can generate the point cloud as well. It is just like lidar point that can be utilized for further lidar classification. And 3D mesh generation options are also available in multiple format. ArcGIS, scene layer package format, OBJ format, and even in the PDF format, GeoPDF format, that options are there. After configuring these things, if I start process, it will process and it will give you the output. As you have seen, Jasprit has demonstrated, he has captured the photographs and processed it and demonstrated it. So such a speedy process is possible here. Now let me show you the output here. So this is the output of the generated from drone to map. It is a complete ortho map. Obviously, very high resolution images, photographs are there. Now, at the same time, it can generate the 3D mesh or 3D buildings also, 3D model. Let me see how it looks like in 3D model. In the ArcGIS drone to map itself, you can see the 3D itself. We can see. So that kind of 3D has been generated here. And we can take this 3D in ArcGIS server as well, so that from our distant colleague can visualize it. Now, as I mentioned, it can generate the point cloud as well. What we'll do with this point cloud? Here, I'm going to utilize some lidar processing software, ENVI lidar, where I have taken all the point cloud here. Here you can see all the photograph. These are all point cloud. Now, options are available here to classify this point cloud into building footprint, location of the tree, location of the electrical line, electrical pole, and so on. Here, it can generate the building footprint in vector format itself. So from here, we have generated the vector data, and all vector building footprints contains the elevation by default because it is captured from the point cloud itself. That vector data we have taken in our ArcGIS Pro. We'll come later regarding ArcGIS Pro in details. So before that, I would like to show you this ArcGIS Pro. Here you can see, so all the building footprint in as it is condition, what are the output we got from the drone to map and lidar, and it is taken here. And how accurately it has captured here, that you can see even the small, that particular object that is also captured. If I see the things from perspective view wise, we'll be able to see like this. See, as it is a building footprint, that's why it is showing the rooftops are floating like this. Here, we have the option in ArcGIS Pro to generate the building block. I would like to generate the building block, and we can get the building block. In ArcGIS Pro, we have the option to attach this building footprint or any other 3D object in the procedural modeling, procedural symbology. Here, I would like to show you some procedural modeling output. For example, I want to redesign or geo-design of that particular area. That way, realistic building footprint or building map can be generated. Options are also available to put some realistic tree as well, so that we can get the complete picture, complete output here. So this is the complete flow from drone to map. This is the input has been taken, we have processed, we have generated the point cloud, and from point cloud to vector map, and from vector directly we have generated for city planning or urban planning. So that is the complete flow of drone to map. Krishna.
Thank you. Thank you, Partha. So friends, you would already know the ArcGIS Pro, which was introduced some 2 years back. All customers who are under current maintenance are eligible for this product. Please ask for your rights, please contact the sales or technical person, whoever is relevant to you. He should provide you this particular product and it can be installed and you can parallelly run along with your ArcGIS desktop. So please go in for this because this is our future desktop. You all need to get acquainted with that. So this is where the ArcGIS Pro is growing. We have added many more functionalities than what ArcGIS desktop used to have it. And now you can have all these extensions also available on ArcGIS Pro. So all the popular ones, the 3D spatial network, geostat, all of those things, data reviewer are now available on ArcGIS Pro. Please take the benefit of that. We are giving it free for all our customers to get for acquittance. The best part is about ArcGIS Pro is now you can customize even the interface as per your requirement. So it actually meets most of your B2B and B2C requirements where you can change the interface of ArcGIS Pro as per your need. It's completely built on Python, so you can scale it up. Integration with R and other systems have become very easy. And then you can even extend it with the .NET, the Pro SDK, which is available to you all. The new thing again which we have introduced here is one of this capability of image georeferencing. And you all know the process of image georeferencing, so I'll not do, but something to watch is the auto-georeferencing tool which we have introduced it. So instead of me speaking, I'll ask Babar to show this to our audience. Yeah,
thank you, Krishna. So do you often have to georeference your raster data sets? So do you find like a lot of time is being consumed in setting up control points? So the auto-georeference tool in ArcGIS Pro is one of the several imagery enhancements so that can help or that help you to speed up your georeferencing workflows. So first of all, using this move, rescale and fit to display tool, I'm going to place my image over the Hyderabad, which I have the image with me. So first I'm going to use this move tool here. So we have to roughly place your image. You don't have to exactly match it. So again, the rescale option here. So once you have placed your image, then I'm going to start auto-georeference here. So the system is here attempting to match your non-georeference image with that of reference image. So the reference image is from World Imagery from ArcGIS Online. So you must be wondering how it's even possible because we are not adding a single control point manually. So the system is trying to match your spectral signatures from the non-georeference image to the reference image across your at different locations and across your image. So normally what we try to do, we try to find out the building cross sections or corner points, street points to georeference the image and to add the control points. And once you add these control points, so we can individually review the residual errors and you can delete the unwanted points. So you can clearly see here, so we got the required control points and upon clicking the control table, you can see all the control points here. So once you are satisfied with your results, so you can go ahead, save it and close the georeferencing. So let's have a quick visual impression of this one. So I'm going to use this swipe option, so you can clearly see the image has transformed correctly. So thank you, over to Krishna.
Thank you, Ajit. I'm sure many of you will get benefit from this tool, which gets in. And you could also see they have used only the ArcGIS Online base map as a reference. So that shows the ability of how the images which we are serving and the capability it has. So moving on to the next, another capability of space-time pattern mining. This is again a tool which comes from the ArcGIS Pro, wherein you can visualize your data in the third dimension too. Here, what happens, based on the data input, what you are getting in, you can aggregate the data in form of a cube to basically find the significant clusters which are actually dominating the impact what you are looking in for, and you can take off your outliers which are there. It helps you in getting both the hot and cold spots to you. So let's see one of the example which we have done for the space-time pattern mining. We have used the example of the recent smog which happened in Delhi. So we got some data from the open source and we have analyzed it and see how space-time mining cube helps you in doing that. So Bawar, can you help me with that?
Thank you, Krishna. So here the scenario is Delhi pollution. So do you know that 35% of this pollution is caused by stubble burning in like states like Haryana and Punjab. So farmers in these states, what they do, they burn their farm residuals or farm waste. So to clear the farm. So here you can see there are like 30,000 fire incidents in Punjab and Haryana alone. So let's see how to mine some special or temporal patterns from this data. So that's why we came with a new emerging hotspot tool in ArcGIS Pro. Because our question is not just spatial, but also temporal. So first of all, using this create emerging hotspot analysis tool, I have created one result here. So let me show you. Yes. So if I zoom to these particular states, so you can, if you click on the results here, so you can see it's a consecutive hotspot over that particular area. And there are some areas which are actually now a new hotspot is getting created in this area. But this doesn't answer my temporal answer, right? So this is just spatial distribution where we can see the hotspot. So to visualize this data in third dimensions, what we're going to do is we're going to use our time as a third dimension. So let's see. So for that, emerging hotspot tool is going to take help of create space-time cube tool. So let's have 3D visualization here. So the result clearly shows here the areas in red are nothing but the hotspots, like this here. And you must be wondering why this column now. The column indicates time. So the top here, the top shows the recent data, and the bottom at the column shows the old data. So you can clearly see at this particular location, there was no pattern first of all. Then for the certain time period that it became hotspot, and then again, it's like diminishing hotspot. So if you click on this particular bin here, so you can check the time period. So I have given 1 week as the interval for this data. So now you can clearly see it normally starts after November or Diwali basically. So to start new harvest. So this information can be used to check the effectiveness of policies or programs that are being implemented or that we're going to design. So thank you. Over to Krishna.
Thank you. Thank you, Baba. The next tool which we are going to look in is about how you can analyze the 3D data within ArcGIS Pro. So friends, we have introduced a new extension within ArcGIS Pro called ArcGIS for Image Analyst. We call it as the Image Analyst for ArcGIS Pro. And the good news is for doing any of these image processing, you don't require any more special analyst. And you can work with that. So apart from that, we have introduced the capability for processing stereo images. And you can also do 3D extraction within the ArcGIS Pro environment. And it also provides you many 3D exploratory analysis of view shed, wherein you can create a line of sight and other view sheds, and even you can create dome tools to analyze that. So this is something which will be of interesting. So Partha, if you can show this quickly to us.
Sure. Yeah, ArcGIS Pro is supporting stereo pair now. So that means you can go for photogrammetric things like 3D viewing using stereo pair or orthorectification, all these tools. Here, we have some data of stereo pair. This is orthorectified data you can see here. And what we did here, we have processed the data in ArcGIS Pro and published in ArcGIS server. And I would like to show you how it looks like if I generate the anaglyph ortho view. So if I have the cyan and red glass, we'll be able to see the 3D stereo here. Not only that, we can measure, we can go for measurement also, and 3D feature extraction option that is also there. In our booth, we have the options to visualize these things using our anaglyph glass. So please visit there to see the real 3D. Now I'd like to show you some measurement here. This is the oblique image. At the same time, there's a base map is there. I want to see that particular area. This is the building actually. I want to see the building from a different direction. How to see this? Just open, click in a different direction and it will be moved that particular direction only. So I'm seeing the building, same building from a different direction. I want to go for a different direction again, I'll get the building will be moved. Now options are available here. If I want to measure this, that options are there. For example, I want to measure here. Let me measure these things from here. I want to measure. So that much of photogrammetric analysis are there. So you can measure these things. Feature extraction tools are also there. So coming back to ArcGIS Pro again. Here I'm going to open ArcGIS Pro. Normally ArcGIS, we work, lot of work we do using our digital elevation model or DEM. Now, how we can utilize digital elevation model differently? So when we work with the digital elevation model, how we can utilize digital elevation model differently, particularly in case in cartographical region. I got some imagery of I got some digital elevation model of Andaman area, and I want to put some different type of look, different cartographical look I want to put here. For example, I want to create some realistic, from the digital elevation model, I want to generate something which is more realistic to the imagery. So that way, here we have the options to change the color format. For example, I want to change the color format, that options are there. So we have to specify the proper range. If I can range properly, so I'll be able to generate the images which will be look like very closely, it will be looks like your digital elevation model. Let's check if I want, here we have the options to put some slightly transparency so that I will put more. Now if I compare with the original image itself from the base map, you can see it is very close to real imagery looks. That way, cartographically, we can utilize digital elevation model. And again, I am going to another digital elevation model, that is bathymetry data of Superior Lake. And this is the digital elevation model. And what I want to give a different cartographical look here so that the original, it looks like water body. Just I am giving that particular bathymetry look, and here you can see it is showing like water. In the background, shaded relief, hillside is there, and it is showing like the water body, depth of the water and reach, everything are visible here. Not only that, sometime, for example, some volcano become activated and lava is flowing on the streams or river. So how to represent it? That is using digital elevation model also. Here we have created such kind of look where you can see it looks like lava only. Lava is flowing on the river. That way we can utilize the digital elevation model. Obviously there is a different way of utilization of digital elevation model. Coming to another demo, there is a new tool, the new tool of ArcGIS Pro. Here in ArcGIS Pro, one tool has been created here. Let me go to a perspective view. I want to see that this is the 3D map of Mumbai city, and I'm going to see the perspective view from a different angle like this. I want to see. For example, I'm standing over the rooftop of the Oberoi Trident, and I want to visualize how much area I'll be able to view from that particular area. Here we have the tools, that is view shed analysis tools. Just click here. You have to do nothing. Click here and you will get this like this. I want to edit something. For example, I want to change the focal area. That way we can change. If I want to increase my view area, we can increase like this. I want to increase, for example, I want to see something more area. That options are also available. We can increase my area like this. That is a new tool is included here in ArcGIS Pro. Now coming to a different location to show you something different. Okay, for example, I want to fly over Mumbai city using some helicopter or some aircraft, and I want to see how I'll be able to view the Mumbai city like this. For example, if I fly like this, what will happen? So these are the red area will not be able to view from that particular flight, and the green area will be visible from that particular flight. So that is the view set analysis that is newly introduced here that can be utilized for your 3D purpose. So thank you.
Thank you.
Over to Krishna.
Anybody from the CEPT University here? Thank you. So this is the example of the CEPT University. We are thankful to them. They have shared us the opportunity to take this data, and we have created a 3D indoor navigation tool using ArcGIS Pro with their data. So thank you, ma'am. So this is which was built. They gave us the building floor plan and the interior space and about the floor's angle and what was constructed. From the engineering drawing, we have built this entire structure out in the ArcGIS Pro, and we were able to create a navigation within that. So let's very quickly see how the 3D routing, the ArcGIS Pro supports it. Bauer.
Thank you, Krishna. Thank you, Krishna. So the scenario is emergency management, that to be indoor emergency management. So in case of emergency, so what we need is, we need evacuation routes to evacuate people from that particular building. So here we have a CPT campus from Ahmedabad. So we have done the 3D indoor navigation for this particular campus. So what we have here, you can see is, I have the campus, a 3D model, which is actually built from CAD, which was converted into a geodatabase, and that data or layers were used to create a 3D networks data set. So first of all, let me show you the internal network here. So we have these three different floors here, and if by using the slider here, I can check all the floors in details, the interiors basically. So you can see the classrooms of the second floor here, and I can use the slider. So now suppose in case of evacuation, so there are some students stuck in like in a particular classroom at the third floor, and they want to use the evacuation route, and they want to just get out the building. So how can you use the ArcGIS Pro network datasets? So let's see that. So first of all, I have created network route here, and let me show you the. First of all, these are my stops, so you can check here. And this is, first of all, this is the entrance here, and the students is supposed stuck here at this particular point. So, and once you run the application, you'll be getting route like this here. So in this case, the stairs are transit routes, the walls are like obstructions, and yes, the entrance will be your final destination. So you can clearly see, these are the stairs here. So that's all. So over to Krishna. Thank you.
Thank you. So you would have seen how easily now we had a product to navigate you outside the building, but now you can also do a 3D routing within the building, which actually helps in planning within, when you have large buildings and malls, you can create this kind of a scenario. So now ArcGIS Pro also supports planetary data. We were able to bring in data from Moon, Mars, and other planetary systems, which can be analyzed within ArcGIS Pro, and you can do it. And the best part being, ArcGIS supports those planetary coordinate systems. So we were probably, as a GIS product, were first to introduce this support. So I would like you to have a look at it. So Partha, if you can showcase.
Yeah, thank you. And I'd like to show you some analytical things, analytical and visualization of planetary data. Before that, as Krishna has, as you know, ArcGIS is a platform for 2D and 3D visualization. Here, the global land cover map has been generated from MODIS data. And here you can see on the globe how nicely we can represent the data. So, and that way it is coming up. Now I'm coming over to India. And as you know, NASA has released their black marble imagery, black marble raster data in 2012, first version, and 2017, the second version. And what we did here, we have just detected the change between change of light. Black marble means how Earth's surface looks like in the night. So we have detected the change, and this change is showing so how light is increased or decreased in the different country. Now, this is showing that whatever the blue light is visible, the lights are increased on that particular area, and pink means light has decreased on that particular area. When I'm coming to the Indian territory, here you can see, here our light has been increased very, in a nice way actually. So that means from 2012 to 2007, it is representing the growth and prosperity of India. Now, this is the looks we get when we see from the sky. But my objective is that how skies looks like from the earth, that we want to know. So here in ArcGIS Pro, we have the option to generate the 3D map or 3D maps of the planets, so different planets. Here constellation map is there, and all the star and galaxies has been downloaded from the International Astronomical Society. The conversion of this data is not easy. Normally the data comes in the feeds format. That feeds format using the Python AstroPy thing and beautiful soap, we have converted this data to TIFF file format, and from TIFF file format to normal vector format that we have taken. So that is the look of the star or galaxy we get from Earth's surface itself. Now, if I want to go for more cartography, I want to represent the sky in a way, in a cartographical way. Here you can see it is showing the different name of the different star is given, Milky Ways are there, different asterisms are given here, polarimetry, polar data is already mentioned here. So that way we can represent cartographically, we can represent our sky at this way. Now in ArcGIS Pro support another type of map creation as well. As you know, for example, I want to represent the southern pole or northern pole, we have to represent like this round shaped map. That options are there, you can generate the round shaped map. Here, ArcGIS Pro giving you the option to generate the realistic map also. For example, this is the map of the Mars that has been used in the globe, it is there. And Jupiter and Moon, all these things are there. As you know, various data are available, including ISRO also giving the data, and anybody can download it. There's Chandrayaan data, Mars orbital mission data, so that can be utilized here. Now let me show you whatever the processing has been created. After that, I have created some webs in here, and that way this is the moon data, lunar data, which is showing these are the area, these are the lunar craters, and if I want to see the lunar mares as well. So these are the lunar mares is visible, and different location of the Apollo landing site that is also marked. So that way we can utilize the planetary data which is completely supported, including the planetary projection, projection system for Mars, Moon, Mercury, Venus, Jupiter, all projection systems are in built condition. It is available in ArcGIS Pro, and that can be utilized. So thank you, and over to Krishna.
Thank you. Thank you, Partha. I'm sure that would have been found very interesting. So we all know the web map, layer, service, they all work together, right? And I need not explain what the services or the web layer and the web map comes in. But typically what happens, the service is a URL where the web clients can access the GIS data, and web layer is something which we are getting it from the portal content, which exposes the data from the portal. The web map combines both of them, and it can help you in doing your mapping functionality. Now at Pro 2.0, we have introduced a new way of sharing this web map data, where map image layers can also be shared as part of your web maps, and there are different 6 configurations which are available, like exploratory, editable, and visualizations which can be done in, and you can share it with other users to consume it. So this is a very effective way of sharing your data. So Bauer, if you can show this quickly to us.
Thank you, Krishna. So at version 2.0, we have extended the idea of connected desktop, so making it even easier to share your work within your organization. So here I have a map of some tax defaulters near the Vijayawada area. So I want to share this information. So I just want to share this information so that people can just visualize. They should not be able to edit or query the data. So the ArcGIS Pro know exactly what we want is cache tiles. So these are the 3 different configurations, like exploratory, which will allow just to query the data, editable, you can edit the data, and then visualization, just for visualization. So once you choose one of them, so ArcMap will take the guesswork and it automatically publish the required layers. So let's have a quick view on that. So I have published the data. So here you can see, this is just cache tiles. I cannot query or even I cannot edit my data. Next is exploratory. Yes, I can do query analysis on this. I can put the pop-up and I can explore the attribute tables. And next comes the editable layers. So you can see I have this edit option here. So you don't have to worry, leave it to the ArcGIS for your sharing work. So thank you, over to Krishna.
Thank you all. So let's move on to our next segment, from desktop to enterprise. So you all would have heard about server, portal, and all those steps. Now, all of these things have been bundled into a single component, what we call it as ArcGIS Enterprise. So now, this ArcGIS Enterprise composes of 4 components. One is your ArcGIS web adapter, which actually can also act as a load balancer. It also helps you in redirecting your URLs to the proper servers. ArcGIS server, which helps you for publishing your services. Portal itself is a mammoth thing where you can manage all your services, users, build ready-to-use apps, and other stuff. ArcGIS data store is something which we have introduced to manage large data sets and allow you to perform seamless queries. So this gives you a lot of performance enhancement. So ArcGIS data store is a very crucial component. If you are looking in for large deployments, this should be a separate box by itself. Apart from this, there are 5 different roles what we are getting in. So when you want to have any of these ArcGIS Enterprise being bought, you can buy different kind of roles as per your requirement. You have a GIS server role, which becomes the base enterprise, image server, the GeoEvent server, the GeoAnalytics, and the business analyst server as per your requirement. So if you want to do the GIS server, you all know, which can serve and manage the geospatial data, and it can also be used for centralizing your GIS data for relevant content. So when coming on to the image server, it's basically for serving your mosaic imagery, and the good part is we don't compress any of these pixels, and even the image service gets to you with a full resolution. So you can do your image processing activities on web, and that's how we are able to do so many of those things using the ArcGIS image server advantages. Moving on to the GeoEvent server, morning you could have seen Josh, and there is an exclusive session also tomorrow, wherein you can track things in the real time. And you can even create event-based alerts based on the data which is coming in. So typically for some of you who are very new to this is the GeoEvent server architecture, wherein now this has got integrated with your big data analytics, where it comes along with the big data capabilities also, wherein you can see GeoEvent server along with my special temporal big data store, and GeoAnalytics server can give you all those advantages. So it is typically like 1/4 core of a server, of a GeoEvent server, can actually stream in data like 4,000 events per second. So that's the kind of ability which we have built in. We started with 2,000, we have reached 4,000. Anybody who wants more of that to be streamed in, you can keep adding boxes as per your requirement. So herein, what we have done is, we have taken one of the startups from Hyderabad, the Indrin, who has developed various IoT sensors for us. They have been marketing, they have different kind of sensors which are available. You can see these are some of those sensors which are there with ThermoLink, which basically gives you a temperature and humidity sensor. Some of this WattLink, which basically plays as an energy monitor and link up. So we have set up a demo station at our demo booth. Post this session, you all can go and see how these sensors work on a real-time basis. So we are trying to mimic one of the scenario of a lake where water is getting filled post rains and other stuff. So I would like Prashant to show us with this IoT dashboard where all these sensors are now live, and you're going to see this thing coming up live. Thank you. Prashant.
Yeah, thank you, Krishna. So as Krishna mentioned, real-time GIS is very critical nowadays. Most of us are working on real-time data. So IoT integration is one critical part where a GeoEvent server helps you to connect to any sensor what you want to. So we are trying to bring to you like an integration where the sensor is shown there in our demo booth. You can come and have a look, which is a water level sensor. So when it detects the water level depth from where the sensor is kept, and the dashboard will give you a simulated model where the water body changes according to the depth of water level change in the tank, what we are trying to simulate. So it can be a case where you install the water level sensor on a lake or a reservoir or a river bank to analyze the water level, and which helps you to find out if the water level increases. That can be brought into a dashboard, which will help you to simulate a model and it can also help you to create alerts when specific water body level increases to a limit or beyond a limit. It triggers alerts for you in a dashboard or in a mail or in SMS. So we have configured both humidity and temperature sensor as well. Probably you may have an attached GPS, embedded GPS along with your IoT sensor, or you may not have it. But if you have an existing location where you are going to install it, that can be enriched using your GeoEvent server, and that can be brought here into your layer, and that can be displayed on a dashboard. So we wish you come and have a real-time look how this integration works, and when water level changes in the tank, how it can simulate the lake display on your dashboard. Thanks.
Thank you. Thank you, Prashant. So let's move on to the next segment. We have seen the portal being done. Now, in the morning, you could have seen there are multiple portal-to-portal collaborations which can happen now. So if you have an organization where you have your master portal, there could be many other departments who can maintain their own portals, and a seamless collaboration between these portals can happen. So wherein you can see an exchange of information happening without any physical movement of the data to happen, then you can even send in alerts to them, and they can even in turn release it to the public. So here you can see this is one of the very typical example of where the city administration, being the master host, they have created a collaboration workspace. And some of those associated departments of community development or a public works or the finance and the transportation, they are sending in seamless communication to them, and even the content and the applications can be seamlessly exchanged between them, so that no need of further integrations or any other custom efforts to be done. So let's see how this can be happening in, wherein you can see some of those aspects of how the collaboration is actually happening in. So Shanmuga, if you can help with us.
Thanks, Krishna, for enlightening us with emerging technologies in our Esri Enterprise family. In this scenario, we are going to discuss about organization-to-organization collaboration. So in this context, I have two portals. Municipal Governance Department, who governs the public assets. Second, the Roads and Highways Department, who manages the traffic operations for the entire city. So creating a collaboration requires collaboration name and then description, followed by the workspace name. Workspace is nothing but a project book or a theme used to organize the contents in your collaboration space. So the last thing in setting up the collaboration platform is to link a group where you can share the contents. Here in this case, I'm going to use the street closure group and proceed to create the collaboration. Here you can see the collaboration has been created successfully, and the next step is going to invite the guest organization. Here in this case, our guest organization is Roads and Highways Department. It requires portal URL of guest organization to be feeded and setting up the access mode. The access mode is nothing but how you want to manage the content. Either it want to be a single direction, I mean you can send or only receive the content, or else in the bidirectional mode. In this context, we want both the organizations to share and receive the context and proceed to create the invitation. So once the invitation is created, it has to be imported into Roads and Highways Department to join the collaboration space. So once you accept the invitation file, the response file will be generated as an acknowledgement token for the collaboration space. So here you can see the status of the guest organization, that is Roads and Highways Department. Still it is not yet joined. So to join, let me join with the existing group named Transportation PWD. And it has been successfully joined. Switching back to municipal governance department, you can see the status of the guest organization, it's still pending. So here in this case, I'm going to accept the guest organization with the help of acknowledgement token that is received from Transportation Authority. So now you can see the status, the collaboration space is activated. So in this way, you can create an easy way of joining the many organizations, as Krishna has mentioned about, as one city administration can have multiple portals that can collaborate and they can work together. So moving on to the next scenario, we'll be seeing about how the contents will be shared in a map-centric manner. So as you know that street closure groups, it is participating in the collaboration space. As of now, you can see there were no contents that is expected. So moving on to the application part, let me zoom to the area where the road maintenance activity is happening. And as a GIS analyst from the Municipal Governance Department, let me initiate the road maintenance activity, as you can see in the map. So the next part is about to send the notification status to Transportation Authority or the whomsoever the organization you wish to send the notification. So switching to the notification app, which is configured in a Transportation Authority department, let me check whether any notification has been received or not. As you can see, the notification has been initiated, and I'll be sending my opinion whether you can proceed or not. So I don't have any objection in this case, so you can start proceeding with your work. So let me update it, and then let me refresh the application once again to get the data updated. And now you can see the notification status has been updated. Objection status, it has an objection, but yes, anyhow, I can acknowledge it. Acknowledge the response from the two department portals. And moving on to the routing application. Now, as a Transportation Authority, now I knew where exactly the road maintenance activity is happening. So with the help of an ArcGIS network server, what I can do, I can reroute the plans by bypassing the road activity which is happening. As you can see, it is considered as a line barrier, and the stops, let's say for example, I want to commute from the point A to the point B, I can generate the alternative route, and I can propose the expected result to all of the stakeholders. Thank you, Krishna.
Thank you. So you can see now these collaboration used to earlier take some months or weeks to configure and do that. Now it's just a simple configuration which actually helps you in doing this. Let's move on to the next segment of GeoAnalytics server, where we are going to process streams of data which are coming in and try to see if we can come out with some kind of a pattern. You would have seen in the morning some of the presentation where Josh has shown about the collision scenario. We'll try to see if we can get some of those patterns which are coming in a different mode. So here what happens, we are getting the information in form of a location, the time, and that becomes my geo event. So this geo event can give me, some of those things can be dynamic. So especially like if the information is coming from vehicles, satellites, or other vessels. This could be discrete also, like something which have just happened. So it could be anything like a lightning or an accident which could have happened to it. And something, it also could be stationary, wherein you have weather stations or a traffic sensor or something which is giving change to it. So all these things has that information along with it and a location to it, and the GeoEvent processor, the GeoEvent server, actually in combination with some of the geoanalytic tools, can bring out a pattern in it and it can actually give you a lot of sense into data what you are doing in, a meaningful insight. So how can this is happening? It is actually happening because of this data store, which is actually making all this happen. Even though there's just streams of tons of data which are coming in, you can see from the one node to other, there is about 4,000 events per second. The kind of transactions are happening in the similar way. The data store is able to absorb that and then able to respond at the same speed when it is receiving in it. So with this combination of this facility, you can see we can come out with a streaming of the real data, which can be coming in form of an IoT sensor. You have those observations, and then using the geoanalytic tools, we can come out with the patterns to it. Let's see some of the examples of the real-time air traffic over India, and also a scenario of some of the ships which are running around with the AI streams coming into the GeoEnt processor. So I think let's start with the aircraft data. Yeah. Over to you, Prashant.
Yeah. Thanks, Krishna. So this is flight aware streaming, which is coming in. We are getting live feeds of position of aircrafts, which is coming from flight aware. We could read that using GeoEvent connectors and just pushing that as a stream onto our dashboard. So that is one thing which you can do simply with GeoEvent server to create a dashboard and show your data live. Secondly, you can push this data into a spatial temporal big data store, which is an archiving and storing mechanism, which also helps you to create automatic aggregation and binning when and where the data comes, which will be high velocity volume data coming in into GeoEvent server. So once you create this and creates these GeoEvents and push that into a spatial temporal big data store, you will be able to create dynamic map services and feature services on fly. You do not need to manually interfere and create specific map services and feature services. So I am consuming these map services and feature services into my dashboard, and I'm just opening my bins. So globally, the data, which is millions of records which are coming in per second, will be getting written into GeoEvent server and into a spatial temporal big data store, and dynamic binning will happen. So in a larger scale, it will aggregate into you can define what would be the scale you require. So in a smaller scale, your bin size will be larger. You further zoom in, you can identify the patterns coming out of it. You can locate so in this scenario, this will be your airports, and you can see how many flight feeds are coming in that specific area, and you can derive a pattern out of it. You can derive the flight paths from this. There are combinations, like so further if you zoom down, you can see the live flight paths which are there, and you can aggregate those values. So I accumulated millions of records, and I could find out the departures happen between Mumbai and Delhi airport or multiple airports across globe. So if you zoom down, you will get that values labeled also, the exact values which are coming in from the data store. So this is one capability which is by default you will get along with your GeoEvent server and spatial temporal big data store configuration. So moving on to another demo which is similar to this. Instead of flight feeds, I am taking out some of the ship feeds which are AIS feeds. So AIS streaming are coming. So I just stored that around 6 months data it took, around 5 million data, and I could perform a density analysis using GeoAnalytics server. So the same spatial temporal big data store on multi-node will be consumed either on ArcGIS Pro or on a web interface. You can consume these data sets and you can perform various analysis, like density analysis is one among them. So you can see here I have received some data across this Denmark area where AIS density of all vehicles I have mapped, and I could even segregate that according to the ship type, which is pressure, density pressure across this area, and passenger ship pattern, which you will be able to derive from which from the data which is stored in the spatial temporal big data store. Interesting part is like your fishing segment also will have some pattern, like how your shipping vehicles are moving from your port to the open sea. So that pattern can be evolved easily using GeoAnalytics server. Further, to take this into a different level, visualization of this kind of data into 3D. So from this, I can create a 3D representation. So say, for example, the same flight aware data feeds which I could get, the departures happened from Mumbai and Delhi in last 1 year, or from January to November. So here you can see this visualization gives you departures happened in each airport. From Mumbai, it's almost 64,000 departures till November. This will help you to predict it for future also. So now this is a 3D representation, JavaScript API 4.0 onwards, you will be able to consume stream services on your web applications on 3D environment. But till now we were consuming this on a 2D environment. If you want to represent those values, say for example aircrafts or satellites, if you want to showcase, you will be able to stream it on a 3D environment. Now, to create an animation out of it, so the same live flight paths I have taken, the data injected is the departures and arrivals happen between airports, which I took, and there are two options. Either you can consume this inside a JavaScript API 4 onwards, or you can consume this inside a portal using 3dfx widget. You will be able to create an animation which is like this. So this will help you to represent your flight movements and the data streaming happening between airports globally. This is for the appreciation of data in a better way. So a combination of GeoEngine processor and GeoAnalytics server will be helping you to interpret and derive much more meaning from your data in an easier way. Thanks, Krishna.
Thank you. So dear friends, there was not a single code written for what all he has done. So this is all a simple configuration by which he was able to achieve this. So please take advantage of these functionalities which come up to you easily. So let's move on to another very powerful API from the SRA family, the ArcGIS API for Python. So here is where your third-party integration and other stuff can be done very easily. So we are talking about R getting integrated. We can have SkyScat algorithms and other algorithms which are there from the open source can also be integrated for getting meaningful deductions from there. So in this API for Python, you can even attach your big data store data, and you can run those analytic notebooks within the Jupyter Notebook framework, what we give you. So you can have your documentation and the analysis also being seen simultaneously, so that when you want to convert this into actual project, this becomes very simple, and you can use these core tools into your application and come out with a large kind of an application to it. Let's see one of those examples about how we are able to count features from the satellite images using the Skikit algorithm. So, Pugal.
Thank you, Krishna. So, let me introduce you to the field of computer vision and machine learning in conjunction with GIS in ArcGIS Enterprise environment. So, what is the field of computer vision? Computer vision using machine learning and artificial intelligence. Computer vision is a field which lets you train your machine, computer machine, to see the image and interpret the image automatically. So there are many different type of libraries present in Python which will help you to do the same. So one such is scikit-learn algorithm. So this machine learning computer vision algorithm lets you interpret the data automatically. And currently I am going to use Landsat data which I have hosted in my ArcGIS image server environment, and that I'm going to take an extent in which I have to interpret and count the number of circular features, which are nothing but centrally irrigated pivot forms. So these are the ingenious way to efficiently manage the agriculture in a water efficient way. So let me just run the analysis here. So let me just open the extent. This is the natural color composite of the centrally irrigated pivot forms, which is present in the middle of a desert. So as you can see here, I have to interpret and count the number of forms in this image. So how will I do it? So I am going to use this image, the machine learning, the computer vision algorithm, which is scikit-learn, with the help of Python API, which was introduced last year. And the image is hosted in the image server of ArcGIS Enterprise. Next, I am running a raster function and applying it on the fly using the image which I have shown you. And I am stretching it on the fly and creating an NDVI and creating this black and white contrast, high contrast image in order to delineate the number of forms which are present in the, our area of interest. So in my subsequent code, in the Python, Jupyter Python notebook environment, I am plotting the same in the matplotlib, using the matplotlib library in the grid format. So after plotting it in the grid format, now I can go on and count the number of forms in the same image. So this particular algorithm, let me count the number of image using the blob detection algorithm.
ArcGIS Pro now helps you generate vector caching for this, and you can actually take much benefit from that. The vector tiles can be, the best thing is it can be built and updated much faster, and multi-scale maps need not to be authored separately without duplicating. You need not duplicate it. From there, it takes it up. And the best is it has got a capability of dynamic labeling, and you can label and rotate them as per your this. And the symbology, and here one of the benefit is the user can, end user can get their own style updates. How they can also allow them, if you can allow a vector style modification, the end user can modify the styles as per his desire. And these all can be done through the root JSON, from the JSON stuff, wherein he can just update the vectors as per his desire. Subject to that, you allow them to modify the stuff. So let's see one of the vector tiles, how this scenario can look in. Shanmuga, if you can help us with that.
Thanks, Krishna. Thanks, Krishna. Let us see why we need to switch vector tile base map service. First scenario is about the size of the vector tile that it occupies the disk storage space. Imagine that a highway patrol department has a WebGIS application to monitor their patrol vehicles. My application currently it is using OpenStreetMap. So for better visualization and the clarity, I need to create my own base map service. In a traditional way, I am using ArcMap to create the raster tiled service. But here you can see the total estimated cache size is about running in hundreds of GBs. To overcome this, ArcGIS Pro, which provides you the facility to create the vector tile map service, and that it can be hosted in ArcGIS Enterprise environment. So the key takeaway is vector tile occupies very less storage space in terms of, you can say, hundreds of MBs. So moving on to the next scenario, I have received a request that I need to update my existing base map service. Let us see the vector tile base map service, how does it looks. You can see for the better visualization, as per your requirement, you can design the symbologies and all those stuffs like labeling, you can do it. So the next scenario is that how faster I can build and update the already existing published vector tile base map service. So let us see how can we do it. So just by updating the style file, you'll be able to achieve the workflow what we are looking for to change the symbology of the existing service. So these tile files are in the form of the JSON format, which comprises of symbology, that what to draw, when to draw, and how to draw. So I have updated my style file, and let me refresh the application. And I'm going to access the same base map service. And here you can see only the routes has been highlighted within a few short span of a time just by updating the configuration files. So the key takeaway is about you can quickly update and build the existing services without publishing a new service. So moving on to the next advantage is about the rotation of the 2D map. Here you can see the maps are getting rotated. In spite of the rotation, here you can see the label properties are getting preserved, like its angle, the position, the texture, and the font. Coming to the next advantage is that based on the system clock timing, you can switch over from the day mode to night mode, that as per your requirement. So these are some of the USPs of vector tile base map service, that you can harness the power of ArcGIS Enterprise, that it gives you the way and you can utilize in your future projects. Thank you all. Over to Krishna.
Thank you, Shanmugha. The next interesting stuff is about the smart mapping. You would have all seen, like, you can simply drag your CSV on Excel onto the map and you start getting your meaningful outputs. And similar to that, there are many, many more capabilities which has been added up onto the smart mapping, wherein you can generate very quickly the heat maps and other color maps from the point maps, which you can deduce it. And now, in addition to this, you can now even bring in animations into it just by mere configuration. And you can see your efforts for developing an application has been reduced drastically. And if you can take this, so always try to see in, like we say, configure first and develop later. So that's a kind of a mantra. I think, Shanmugha, if you can show us this smart mapping.
Thank you, Krishna, for briefing about smart mapping. So let us see what smart mapping can do. I received an air quality file for the region of Delhi with various parameters. So smart mapping function allows me to plot the locations just by drag and drop. Smart mapping function, it auto scans and the deep scans your data and suggests you the symbology based on the attribute values. Here, in this case, I would like to change the value of PM 2.5 and let us see the changes on the map. So without using any geoprocessing tool, I can generate the heat map, and you can see where exactly the concentration of PM 2.5 is occurring. Let us explore some of the properties of heat map. I'll be able to change the symbology of the heat map and the area of influence which is generated due to the heat map. You can adjust it based upon your requirement, and the transparency based upon your project requirement, where you can overlay the various types of layers from ArcGIS Enterprise environment. So moving on to the next scenario, here I would like to identify the predominant category of the particulate matters among the existing data. With the help of a comparative symbology, I should be able to generate the clustering of the existing air quality information with combination of various parameters. Like here in this case, I would like to compare SO2 with PM10, and here you can see the changes. And adding an additional parameter like carbon monoxide, and you can see the changes in the map, and the heat map has been overlaid on it. And I would like to identify the predominant category based on the volume of the concentration. You can change it using the predominant category and the size parameter. So moving on to the next scenario, here I would like to identify the average concentration of particulate matters in each ward. So how can I do it? So there comes the portal analytics module, where you can access these tools either in the browser as well as in the ArcGIS Pro environment using the feature analysis module. on executing this aggregation tool, let's say, for example, Delhi air quality will be aggregated to each ward. And the best part is that web tools provide you the facility for computing the geostatistics as well. Here you can see I'm computing the average values for each parameter for each ward. So on execution, you'll be able to see the result in the form of 2D map. So all your values has been aggregated to each ward of the average concentration. So for pleasing visualization, let me take you to the world of 3D. So how we can visualize these computer results in the 3D Smart Viewer that is exclusively available in ArcGIS Enterprise environment. So let me zoom to the PM 2.5 concentration. Here, the 3D bars represent the PM 2.5 concentration against each ward. Let me enable the other parameter, ward-wise PM 10. And here, at the bottom, you can see the values of each ward of the PM 2.5 concentration. And the extrusion of the polygons, you can see for each ward that is based upon the PM 10 concentration. And let me enable the other parameter, ozone intensity. So how much it would be in each ward. Let us zoom to that, and you can visualize it. The circles are pulsed out based upon the ozone intensity. And finally, I'm going to enable the CO, carbon monoxide concentration. And here you can see the values are getting integrated together in the 3D environment, and is getting pulsed out. It is getting pumping in and pumping out based on the concentration. The best part is that ArcGIS Enterprise environment, as Prashant has mentioned about the live feeds and the IoT can be integrated together to harness the power of exploratory, multidimensional exploratory visualization in 3D format from any device, anywhere, anytime, across the globe. So that's the power of ArcGIS Enterprise. You can harness it. Thank you, Krishna.
Thank you, Shanmugha. That was amazing. So let's move on to the next segment of CityEngine, which again continues to the world of 3D. So you have seen lots of 3D stuff, and let's see something on to the next dimension of this. The CityEngine, actually, this is one of the products which has been acquired by us some few years back, and many of you who would have seen Zootopia on the cars, that's all has been made from CityEngine. So this actually helps you building your 3D environment faster, smarter, and the easier way. And you can see that's how it enables you to do that. So you can see in the CityEngine, apart from creation of your 3D city, we have now introduced tools for your visibility analysis. So basically, when you want to see at different heights, how the visibility will be there, and with the buzzword of having the green town or a green building, these kind of tools can actually help you from the planning stage itself. And we have also introduced of editing and changing on the dynamic editing over the CityEngine model so that you can see the results very quickly. So I'll ask Sharath if you can show us the local edits and the viewshed analysis from using CityEngine.
Thanks, Krishna. This is the area I'm going to show you right now is the new capital of Andhra Pradesh, Amravati. So being going ahead for the functional and all, the first requirements is to establish the administrative offices over there. Now they have came out with construction of administrative offices over there. The main capability of CityEngine is we can be able to design the existing structures, and even we can be able to design out the conceptual structures for the planning and designing. So let us see what are the existing structures that are present with the present Secretariat of Andhra Pradesh. So this is the built mode of them, and this is the current road availability for the new Secretariat of Amravati. And there are various levels of detail we can be able to design out using CityEngine. And currently, the designs, what I'm going to show you is LOD of 2. It's called level of detail 2. So we can be going for the navigation across the 3D content that has been got generated. So this is the buildings of Amravati Secretariat. And in order to optimize the amount of sunlight that has to be reaching into the building and all, they have gone for the gable roof design. This is the central roof where a gable roof design can be made with little offsets from the top of the building. So this much precision and accuracy of variation in the lens, we can be able to design it out. And the parking space that is available outside the secretariat. So this is the parking space available. And this is the open green space that is available inside the secretariat. So consider all these things, being the new development and all, the secretariat, it should be having enough amount of security and all. So let us see how dynamically now a conceptual building can be erected out. Now this is a conceptual building, the security building, which is not existing currently. We want to enhance the security for this secretariat. For that purpose, from the release of 2017.1, the takeaway for our customers could be the view shed analysis can be made it out dynamically at nature. So let us go for visualization of each of the cameras. CCTV, let us assume that CCTV cameras has been positioned on the security building and how we can be able to take it out. So before showcasing that one, we want to show one more capability called local edits, where we can be able to interactively and dynamically edit the buildings interactively. So just by hovering this, we can rise the structures of the building dynamically. And this has a simultaneous interactive interface where we can be able to showcase what is the amount of gross floor area for each of the segments allocated inside the building. So let us bring back the structure to its normal position. And now let us see the position of this security visualization here. So this is the view. The security cameras has been positioned here, the CCTV cameras. So let us go for enabling each of them now. And the view shed analysis will be enabling us. So this is the first camera, what we are seeing here. And that is its instantaneous field of view. Horizontal angle of view is 75 degrees and vertical is of 30 degrees. And when we enable that CCTV camera, this will be giving us a dynamic way of visualization. So which are the areas in the green that are visible and which are the areas which are not visible. So let us enable all of the cameras that are present within our within the secretariat and see which are all areas that are visible. So in the planning scenario, this will be enabling you a cumulative view of how the entire visualization mode, entire area can be covered with respect to CCTV cameras that are placed across this campus. So in this way, this will be so helpful for you in a cumulative way how your things will be enabled. So if I think I might be taking a different way of scenario, I want to change the angle of view for this particular instantaneous field of view for this camera. We can be able to dynamically take out the things by rotating it dynamically. So automatically you can be seeing the instantaneous field of view of this particular camera has been changing. So in this way we can be able to dynamically trace out the things and enable the visualization. And even we can be having one more analytical capability here, where it is called view dome. If you want to really experience the things that are present across you in a 3D environment, we can be enabling one of the elements called view dome. And that shall be giving you the perception that when you're traveling, being not present, which we can be knowing the virtually how the things can be happening on the ground. So this is the view dome that is happening. And we can be having the perception of 360-degree view of this dome. So in this way, we can be able to take out the real functionality of CityEngine, which are some of the few of the takeaways. Please come to our booth for having a detailed new enhancement that has been happening for the CityEngine. Thanks, and back to Krishna.
Thank you, Sharat. So we are moving this on to one more step of where we can take this into the VR environment. The CityEngine actually helps you in exporting into ArcGIS 360 VR, which can be taken in by the VR environment, enhance it, and create you a real VR experience. So we have our startup from Hyderabad, Mauritius, Mr. Hassan, who is going to actually help us. This startup has integrated this particular solution with them, and you all can really experience this VR ability at the stall where you have put up. We will request you all to experience it. So Hassan, it's all yours, where you can talk about.
Thank you, Krishna, sir. Before I begin, though, just so I understand, how many of you have heard of augmented and virtual reality? Decent number of hands. How many of you have tried augmented or virtual reality? A few. And the most important question, how many of you want to try? There you go, that's much better. All right, this is really exciting. So all day we've heard of the impressive new capabilities in ArcGIS, which working with 3D data and exporting it out of those environments. The question comes, why are these technologies coming up? It's because human beings tend to prefer 3D rather than 2D. So when we see something, when you're able to touch it and interact with it, it's much more immersive and much more powerful than when it is locked behind a 2D screen. So you have immense capabilities in ArcGIS, and you're able to generate this data. How do you bring it into these environments? How do you bring it into augmented or virtual reality? And this is where we come in. So our platform, RED, is the world's first augmented and virtual reality authoring tool for non-coders. So that means today you can start using it and taking all your GIS data, the complex digital data, into the real world and start using your hands instead of your mouse to touch it. Use your feet to walk around it instead of a keyboard. So I'm just going to give you a quick preview of how this can happen. So we're going to start off with CityEngine. We have a few pre-generated models. We're just going to select the area of interest. You can do an area of interest or you can do the complete environment. It's up to you. So we'll export it out. This is a powerful capability built into CityEngine to export an FBX file. We have to do a few minor settings. And it generates all the necessary files. So this is where the folder is. It will populate it with the generated files. And it's ready. So we'll take a look first to see how the 3D data has been generated. This is in a neutral 3D file reader, just so you understand. And it'll help me set the context for what's going to happen next. So you can see the buildings which we've been able to extract, the roads, vegetation, cars, etc. And we're going to go into bringing this into the RED editor. So in the RED editor, this is how it looks like. All we're going to do is select the 3D file that we want, click on import, and this is a real-time video, by the way, so everything that you're seeing is happening in real time. That's all it takes to bring the file into the RED platform. So we're just going to make a few adjustments. I have my friend there, I call him Bob. He's just going to show you where you're going to start in the VR environment. So in this particular case, I'm going to put you onto the street level view. So you're going to feel like you're standing there, and that's how you're going to feel like. So we're just going to set a few options in RED, and we're going to publish the file. And there we go. This is the same file in virtual reality. This is how simple it is. As you can see, you're starting off where Bob was. You're able to look at the street view, look around, and a very powerful capability is the ability to teleport that allows you to move around in the complete environment. These are a few of the additional features that we have in RED. There you go. It's as simple as that. Today, RED supports HTC Vive, Oculus Rift, Microsoft HoloLens, and the Samsung Gear VR. So if you'd like to experiment with any of these platforms, it takes a few clicks and you'll be there. Thank you very much. Over to you, Krishna, sir.
Thank you, Hassan. That was really nice. So this is to our last demo before your long-awaited tea break. So Vaibhav, if you can come up for this. So this is again a new introduction again on the ArcGIS Pro. So we call this the pipeline linear referencing system. Many of you would have known the linear referencing systems where we plot all the assets and other environments within just by using measures and distances. There is no coordinates in this stuff. Especially if you can look at the roads department and the pipeline industry basically works on measures and distances. Even some of the mining department also work on the measures and distance. So ArcGIS even supports such kind of an environment wherein you can just mere using these references, you can start plotting your data in the GIS. So this PLRS, the kind of pipeline referencing, can actually help you in meeting all of these requirements, where I'm giving you over the pipeline from asset development to customers and regulatories, wherein you can meet it that. So this is where the ArcGIS pipeline referencing is happening. You can see there is a linear event, and down there is a route where with a distance which is there, and there are no coordinates here. And this enables to basically measure those values. Using the LRS tools, you can map it on to the ArcGIS Pro environment, and you can extract the information from there. So this is where you can see the ArcGIS, the project toolbar, wherein look like you can actually create, realign, or even extend the pipelines as per requirement. So you can plot your pipeline, and then followed by assets, which can be done over that. So let's see the quick demo from Vaibhav on the ArcGIS pipeline. Over to you, Vaibhav.
Thank you, Krishna. So this is our area of interest. It's Bawal region in Haryana. So we already have an existing pipeline there. And in this demo, I'll start with adding that additional pipeline which is proposed. So let's zoom into the area. So this is our existing pipeline. So let's select the center line and add this tabular data. So the data which we have is in the form of measures and distance. And the technical term for that, which popularly is used, is chainage. So we can see the pipeline chainage information. This is here in meters. And then another, you can add assets, events. So in this case, these are boreholes which have the soil type information, as well as at what depth that particular soil type is, and the chainage information at what location along that particular route that particular borehole is. So let's add that new proposed pipeline. So we'll start by selecting a center line, and we'll create a pipeline. Just name it. So of course, a pipeline has a life cycle. So we'll select a starting date. So as it's a proposed pipeline, let's select this date. And for creating a pipeline, we'll go with giving it a chainage information. Now, as we can see here, we have our new pipeline, which was proposed. Now let's switch to the 3D view and see what value addition we can do on LRS using ArcGIS Pro's 3D capabilities. So again, this is the base map is imagery, and we'll go to the storage area where these oil is stored. So ArcGIS Pro's 3D capabilities gives us a lot of control over animation and models. So I've also added the texture there. And now we'll move on to more value addition, what we can do here. So I have added the plant walls, and these green line is the place where the pipeline is below the ground. We can have some road objects, and then direction markers for visualization. Added that pipeline. So that's how the synergy is between the 3D and 2D view, and how we can add this measures and chainage values directly into the ArcGIS Pro using its LRS extension. Thank you.
Thank you. Thank you very much, Vaibhav.
Thank you very much, Krishna. Hello, everybody. Thank you for coming to today's session. My name is Cherie Muleh, and I'm from Harris Geospatial. And I'm here today to tell you a little bit more about the technology portion of what we have to offer within our software. So some of the main products that we have are our ENVI image analysis solution, our IDL programming language, Jaguar web-based imagery management and analytics, and our geospatial services framework, where we take all of our solutions and bring that to the enterprise. What I want to focus on here today for you is our ENVI image analysis software. You've heard our name mentioned throughout a variety of the different presentations, and you've seen some of the different components of ENVI being used already in some of the presentations today, where we're talking about data analysis and imagery analysis. And this is what I want to focus on here for you. We are the leader in image science, and we are the imagery analysis partner of choice with Esri. And our software is used by GIS professionals, scientists, and image analysts all around the world who are looking to be able to get better information from their imagery and make decisions about the different workflows that they're looking to achieve. Some of the main capabilities that we have for ENVI are shown here, and we're using all of our proven analytics to deliver our expert level results. And many businesses, organizations, clients, they choose ENVI because it integrates with their existing infrastructure, their existing workflows, supports all of the most popular sensors, and can be easily customized to meet any of specific project needs. Some of the main reasons why our clients keep coming back to us are listed here. One is our extensibility. So all of the image analysis tasks that you'll learn about here today, that you've seen in other sessions, these can all be customized depending on if you have some specific needs that you want, a specific algorithm that you want to introduce and do some research on for image analysis, or build your own toolboxes. This can all be done using ENVI. The reason also that we're here is that we have the tight integration with ArcGIS. So our development team and the Esri development team have been working closely together for many years to be able to make sure that our software runs together. And all of the ENVI workflows and tools, they can be opened in the ArcGIS toolbox. Results can be pushed directly into ArcMap, run as a GP tool in ArcGIS Pro, which I'll show you in just a little bit, and also work ArcGIS Online. So this way, you can take all of the ENVI image analytics and we can deploy them anywhere. Desktop, enterprise, ArcGIS environments. And with this, this gives you that complete geospatial analysis platform for doing all of your advanced imagery analytics. Data support is probably the main reason so many of our clients come back to us, because they just want to be able to read their data in, whether they're working with multispectral data, hyperspectral, LiDAR data, thermal, SAR data, aerial data. The first thing that people need to do is say, I just want to be able to read my data and take a look at it and then start doing analysis on it. We support all the sensors and platforms and data formats, so this can be automatically read into our ENVI package. We offer so many different types of analysis tools, and these can be built as workflows as well. So this leads you through a workflow from beginning to end so that you can get results that you need quickly. Now, a lot of the image analysis tasks that we have are part of the core software, but we also have a number of modules that help deliver some specific functionality that you may need for your particular projects. And these ones are listed here for you. Whether you need to do some advanced feature extraction, or creating DEMs from imagery, or doing atmospheric correction, these are some of the advanced capabilities that we offer to make sure that you can do the results that the analysis that you're doing to get the best results possible. We need to do these tasks to make sure that the results that you're looking for are done correctly with scientifically proven algorithms to make sure that you can get what you're looking for. We also have some very specialized packages for working with more complex data types. So for many countries around the world and in India, where we have challenges with weather and cloud cover, we need to be able to collect data and do analysis day or night, irregardless of cloud cover. And the perfect solution for working on this problem is using SAR data. We have the most advanced thorough package for working with SAR data, and that's called ENVI SARscape. And my colleague will be presenting after me to give you some more information about the capabilities of SARscape to be able to work with all different formats of SAR data and be able to actually derive new data products from that you can use within ENVI or within ArcGIS. One of our newer modules that we have has been working with the precision agriculture groups and looking at crop science. And this module is called ENVI Crop Science. And we've been developing this to be able to really understand how to minimize loss and maximize yield from different farming applications. This allows you to analyze multispectral data to provide extensive crop health information. And we do this in a variety of different ways. First, we do crop counting. So any particular type of grown crop that we can see in any type of data, we can go ahead and then count that across the entire field. After that, we can run our advanced analytics on that to be able to understand at the plant level, crop health, vegetative health, soil moisture, chlorophyll level, texture. We can start then looking at trends across the field to be able to help farmers and different agricultural boards understand what's happening at that particular plant level. The goal of this is to be able to then get results that we can actually work with in the particular fields. What's one thing to know what's growing there and identify the vegetation, identify your crops. But what we can learn from that and then be able to give some actions on that. We can understand yield. We can do various hotspot analysis to see an overview of farm health, or get really into row-by-row analysis. What if we had an irrigation failure in some row? What if we had an improper application of fertilizer in one row? What do we then do to understand that row-by-row analysis for the plants? Again, individual plant statistics. What is happening within one particular corner of the field? What's happening within the particular row? Was there a gap in planting? We can do these types of analysis to be able to then understand what's really happening at the individual level of plants. We've been working on this by taking so many of our existing and new scientific algorithms for doing image analysis and bringing that into this new module that we have for our clients to do crop analysis. One of the things that we have that's very powerful within our software package is to be able to do any of the customization that I was telling you about. Now, we have our scientific programming language, which is called IDL. This is one that we've developed, and it's been used by many agencies and industries around the world. Anyone who needs to do some scientific analysis and visualization, and we have unmatched processing speed for complex models and visualizations. It makes it easy to visualize complex data, extract information however it is that you want, and be able to display it. And we can generate animations, PDFs, any particular type of file format. Now, one of the things, too, is that from within our own powerful programming language, we can then connect with every other type of programming language. We have a direct bridge with Python. We have that direct connection then with R. So this is another way how we integrate into the ArcGIS ecosystem by expanding upon these different types of capabilities from within our own programming language. So from here, we can make those bridges and connections and wrap any type of functionality that you're using within ENVI or IDL and bring that into the ArcGIS environment. Now, to show some of the existing capabilities of ENVI and to do some examples of visualization of data set, I'd like to turn this over now to my colleague who's going to show you some examples of visualization in ENVI.
Thank you, Cherie. So what you see right now is not an image, is actually gravitational data and how the gravitational anomaly occurs throughout the globe. So this is from NASA's GRAY satellite. So the bright colors are the positive gravitational anomalies and the darker ones are the negative anomalies. Now, how these gravitational field changes through the different seasons like pre-monsoon and monsoon. So we'll focus on the Indian subcontinent. So let's go here and see the time series, and let's just observe the seasonality in it. So we can see during the pre-monsoon region, the gravitational anomalies are negative, and during the post-monsoon season, the land gets saturated. So that increases the gravity, the surface water and the groundwater. So this insight gives us how the increase in population, the climate change affects the aquifers and groundwater stress. Now, even if we subtract the seasonality in the data, which you can see in the graph, there is a downward trend in the gravitational anomalies. Now, based on this observation, we have created a change detection, and these darker patches show the groundwater stress from 2002 to 2009, and which is probably caused due to the increasing population and the groundwater extraction. And I want to also focus on one of the observation which Giulia showed yesterday. So where we saw the Delhi ground subsidence around the airport area, and the probable cause can be the overexploitation of groundwater. So we can see how all these different kinds of remote sensing data can be correlated and can give us a better insight of how our Earth changes and how the whole planet works as an integrated one ecosystem. Now, I also have few case studies and how gravitational data can give us insight regarding the ice loss in Greenland or the gravitational changes, how they correlate to the 2004 tsunami, Indian tsunami. So for that, you can visit me at the booth and we can discuss this. Thank you.
Thank you. So all of that you've seen here so far is all part of existing functionality that we have in our most current release, which is ENVI 5.4. So that's all available right now. So I just want to highlight a couple things that are coming in our next version, which is ENVI 5.5, and give you a little bit of an idea about what we have that we're working on. One of the things that we're excited about are some new tools for data visualization, image preprocessing, and exploitation to help provide some seamless workflows to be able to help you deliver your final products. One of the things that we're most excited about is our new ENVI modeler. This gives you a capability to be able to now have an interface to link processing chains together within ENVI, and also be able to connect that to the enterprise and also into ArcGIS. Flash is one of our advanced atmospheric correction algorithms. Those of you that are doing change detection and any type of material identification know that doing atmospheric correction is most important to be able to make sure that you're comparing the same materials together. If you're going to be able to detect change, you want to make sure that your conditions are the same to be able to actually detect change and not false change. And one of the things that's been most requested from our clients is a way to be able to batch process that. So we'll be able to offer that atmospheric correction capability now within that batch processing. The next big thing that we have also is our integration with ArcGIS Pro. Those of you that have been using ENVI and ArcGIS together already know that we've had that desktop integration for years. But of course, the next thing that we need to make sure we can do is how do we integrate that with Pro? And then as always, we'll have new data format readers. We're always making sure that we update all of our sensor formats for the next new releases to include everything new that's been launched that we can now support, including WorldView 4, Dolphin 3, and there's even more that's coming as well. Here's a view of what the new ENVI modeler is going to look like. How to help build workflows without having to write any code unless you want to write code also, because we already have that capability with IDL that I showed you. So now you can go ahead and take those different types of ENVI image processing tasks and then string them together. This is like the ArcGIS model builder. Now we have this within ENVI as well. So you can take these different components and actually use them together. You can take these different types of workflow chains. You can automatically write them to an ENVI extension, so then they'll show up in your toolbox when you're using ENVI. You can take this and write this and automatically publish this online. So then you're using this within our enterprise environment, within ArcGIS Online, within ArcGIS Pro. We have all these new ways now you can take these different processing chains and expose them to various users. So this is something that we're really excited about, and we've had a lot of really good feedback from our customers on this particular topic. For our regular desktop support with ArcGIS, we've updated that now, of course, to include 10.5. So that will be current with all of you using ENVI and ArcGIS together to do your different types of imagery and GIS analysis. And the new thing that we have also is our ENVI Py module. So this Python utility will now allow you to run ENVI tasks as a GP tool within ArcGIS Pro. So this is one of the ways that we're using Python and developing these different Python utility libraries to be able to give you access to all the ENVI image analysis tasks within the ArcGIS framework. Here's a closer look at what that will look like when you want to be able to start creating some ENVI tools within the ArcGIS toolbox. So you can see on the left that once you install ENVI and our framework will be able to run this and the Python utility, you'll have a new toolbox that says Create ENVI Toolbox there as a GP tool. All you need to do is give it the specific ENVI task name, and then they'll be able to allow you to run all those new tasks directly within the ArcGIS Pro environment. So go ahead and take a look and show you what that looks like. Here's with the ArcGIS Pro environment. And then what we can do is be able to go ahead and show you what that toolbox looks like. On the right, you see the toolbox that's been installed, which is the ENVI Management Toolbox, and it's a Python utility. All you have to do is create that ENVI toolbox, and by using our task API, which we have all the different tasks documented and exposed, all you have to do is write the name of the task that you're looking to build that toolbox for within the Create ENVI Toolbox environment there. So here we're linking together multiple different types of tasks, including a classification, various different spectral indices, an atmospheric correction task. The next thing you do is select your output toolbox, and this is just the name of the toolbox of where these new tasks will reside. Go ahead and press save, then we'll run the process. Now here within ArcGIS Pro environment, this will go ahead and create that new ENVI toolbox for you, and it'll contain now, once we add that in, those different tasks that we had just created and specified. It can be one task, it could be many. So here now we have that ENVI toolbox, and listed there within the spectral indices, now are all the different indices that ENVI ships with. We ship with 66 different spectral indices to allow you to do different types of analysis. So we can go ahead then and select one of these that we want to do analysis on. In this case, we'll go ahead and select the NDVI, and then it'll use our existing data set that we have open. So then we'll go ahead and run that, and then now you get those results directly within ArcGIS Pro. And this is something that's really exciting because now this gives you the opportunity to be able to take advantage of all the different types of ENVI tasks and run that directly within the ArcGIS Pro environment. Some additional features then I just want to highlight that we'll have in our upcoming release include improvements to some of the band math operations that we have, using the toolbox links then to be able to incorporate even more of the tasks. Those of you using NITIF data, we have module updates for that particular data format. And then we've been working on creating even more ENVI tasks from all of our years of different types of ENVI processing. The way you can think about this is when you look at the ENVI interface that my colleague was just showing you in the demo, all those different types of functionalities have been exposed as part of our task API. So each one of those has a particular task name that you can then call from the different environments. And the additional feature as well that we will be releasing just next month is called OpticalScape. And this is our new product that we have that works a combination with SAR data and UAV data and optical data to be able to allow you to take data fusion to the next level. By bringing all these different tasks together, we can now start doing even more types of analysis online. This is where we're seeing a lot of our clients want to be able to use our ENVI image analysis tasks, just like how you're seeing with ArcGIS Online. How do we integrate these different capabilities together to start running some new different types of analysis? In this particular example, this is a LiDAR point cloud that we have online, and clients maybe want to extract power lines and power poles and be able to locate and identify infrastructure. We can use LiDAR imagery and other modalities of data to be able to make real-world decisions about the energy infrastructure. We can integrate this then with ArcGIS Online and be able to start looking at, okay, what if I extract poles, what is now the demographic information and other information about those poles that we can then do additional analysis on. This gives you full integration with all of your ArcGIS analysis by working with ENVI, doing these tasks online, and having that tight integration across products. This really gives you the full capability of all different analysis tasks within both of the software packages. So thank you very much, and I'm happy to answer any questions after this session. Thank you.
So the next speaker for us is from the sarmap, SARscape, Dr. Giulia Tessari. She is an Earth observation specialist and a marine Curie fellow with MSc in environmental engineering and PhD in earth sciences at the university. She will drive us to the product of SARscape, which is one of like an extension of the Harris family itself.
Okay, so good evening, everybody, and thank you for coming here and being here till this hour, this time. And so I don't know how many of you are familiar with SAR data. Probably, I mainly saw application using optical data or other kind of information. So if you're not familiar, I will try to give you some easy indication to interpret this data, because unfortunately they are not really easy to read and to imagine in your mind, because we are speaking about radar data, so the kind of information you are seeing need to be interpreted. So SAR data are mainly used for several applications. They are mainly focused for displacement information, measurements, for creating DM, or for change detection analysis. But today, I just want to focus on some really specific application, mainly interesting for safety and defense reasons. So in particular, I'm showing you 3 different cases of how SAR data are able to detect objects that are moving or that are changing in time. So as you probably know, the big advantage of this kind of data is that they have no problem to acquire in any weather condition and any light condition. So the first case I'm showing is the detection of some object moving in an area in Syria. This is the study area. Here you can see a zoom. And as you see, it's a really desertic area. So what we could see analyzing some SAR data. Okay, I'm sorry for the quality of the video, but you probably noticed that sometimes some lighting paths are appearing in these scenes. Okay, it's not necessary to go till the end. Here we use all the stack of these SAR data that actually were acquired during the night. And you see the pink path correspond to the area that are affected by changing. In fact, here we created an RGB layer using the coefficient of variation, minimum and gradient. So the combination of red and blue is showing the area that are changing a lot. So what happened here? In this area, the ISIS control went under control of ISIS some years ago. So to have good relation with the local population, they start to extract oil and give it for free to the local people. So during the night, a lot of tracks were coming, and what you see is the path of the tracks that were coming during the night. So in this case, SAR data, even working in the darkness, so in the night time period, in the night period, were able to detect exactly the path of all these tracks that were reaching this city. Then another case is focused on moving target. So what you see here with this rainbow is an airplane. And in the next picture, you can see some cars moving. So how is possible with a single image to detect these moving objects? I'm trying to explain for the one of you that are not familiar with SAR data. So SAR data, SAR stands for synthetic aperture radar. So this aperture antenna, this synthetic antenna is created in this way. So the satellite is acquiring over a certain area, then is moving on and acquiring over another area with a certain overlapping, and then moving on again. So it's detecting the same point from different position. And then this information, the backscatter, is integrated in a single information for each pixel. So this synthetic antenna is used to obtain a really high resolution of the pixel, of the final data. But what we can do is to split back this data, so from the original acquisition, and to see if an object is still there after the satellite is moving on. So, okay, here I show you the panel. We have a specific workflow for the moving target detection. I want to try to show you directly from ENVI what we can see. Okay, this is the same image you saw before, so the airplane. But if I show you, these are one of the layers that were splitted from the original image. And what I can do is to show you this band animation. So actually, 3 bands have been created. And you see that this object is moving in the 3 scenes. So using a single data, we are able to go back and see in really huge area where are the objects that are moving. Okay. So, yeah. Here I have an example of some trains, so we can detect these trains that were moving on the scene. Sorry. Yeah. And some example of some ships. What is interesting to see here is if you carefully look at the image, there are some inversion of the order of the colors. So we are even able to see the direction these objects are moving. I missed an information before. The direction of displacement we are able to detect is along the azimuth direction, so the direction of the satellite flight. And so as you see, the rainbow are always plated more or less in the north-south direction. And from this information, we can even detect the quantity of this velocity. So more or less, okay, it depends from the resolution of data, but we are able to detect objects that are moving of a speed of some kilometers per hour. Here again, you can see some ships and some cars that are moving in this bridge. So this could be really interesting for defense use if someone needs to detect objects that are moving in the night. A last case is a specific tool for ship detection. So this tool is able to detect ships just using this SAR data and as external information, a coastline. So we are going to mask the land, not to confuse the land with the ships. And again, there is the possibility to create a buffer around the coastline because as you can imagine, the water level is changing a lot during time and during different seasons. So we need to be flexible and to adapt our coastline to our scene. Again, moreover, we are able to integrate this information with IS data that you probably saw in the demo before. In this case, IS data are not used, AES data are not used to detect ships, but are used to compare the results with the detected points to see all the available information regarding these ships. So here is the panel, and again, you just easily have to add your images and set some parameters. Here I have some results using TerraSAR-X data. There are 3-meter resolution data. You see we use the coastline, the shapefile of the coastline, and this is the final results. So we were able to detect more or less all these ships. Of course, it's quite important to have high-resolution data to be able to detect really small ships with small size, but also the dimension of the object can be set so that it's possible to discriminate objects with different size. Here is an example in Denmark, and I recognize the same example that has been used so before regarding the density of ships and the path of ships in this Denmark coastline. What I want to show here probably is not really visible, but this green line gives you the information that IS contains. So in particular, this external information tells you the name of the ships, their position, their path, where they are going, even the number of passengers, or a lot of information that every ship is sending from GPS position and all the necessary information. The problem is when we don't find a match with this information. So it means these ships are not sending information. So we are able to discriminate which one shouldn't be there or are not sending information. Here I have also another simple example just to show that I downloaded some free available data, Sentinel data over Mumbai area. So it's not necessarily something that can be done just in other places of the world, but in Mumbai we did the same. Unfortunately, I didn't have the external information, so I couldn't match it. But we were able to detect both ships that were located close to the coastline or in the middle of the ocean or the sea. So thank you for your attention, and if you have any questions, just ask me.
So today's last talk from our partners, Trimble. I think Trimble doesn't require any introduction. I think most of the people who are there in the GIS community know that they are one of the leading makers of GPS and other solutions which is there. So we are introducing the Jonathan Davis, the business development from Trimble. So let's hear from him. Thank you.
Thanks, Krishna, for that introduction. So thanks for sticking around. I know it's a little bit late in the day. My name's Jonathan Davis. I'm from New Zealand. And Krishna, just quickly, I noticed that New Zealand fell off the map on some of the ones we saw earlier today, so we might need to check the live atlas for next year. But I'm work for Trimble Navigate, or Trimble Inc. now, and we're pleased to be here supporting the event again and to be the gold sponsor at this year's conference. And I'm here to talk about Trimble in general, to introduce or reintroduce Trimble to anyone that doesn't know who we are, and also to talk about a new GNSS solution that we have, which brings accuracy on demand as a service to the collector app. So starting with Trimble, I started back in 2000 when the company was about 1,000 people and was doing about $400 million in revenue. And over the last 17 or 18 years, we've certainly grown up. So we're now doing about $2.5 billion in revenue. We've got 8,600 employees across 39 countries. And for India, locally, we've got about 1,000 employees spread across 8 offices. So for Trimble, India is a very important region, both for us, for our organization, and also for the markets into which we sell, of course. The way that I describe Trimble now is we are an organization that develops measurement and positioning, hardware and software solutions, and we sell those solutions into a number of different industries. And the industries that we focus on are on the screen up there now. So the 5 across the top are the industries where we have the most focus. And of course, where I'm from is the business that sells products into the geospatial market. And then we have a number of emerging businesses within Trimble as well, and there's just a small number there. I think the total number within the organization is about 30 different emerging businesses. So this is just a small selection, but anyway, it shows that we've certainly grown up since we used to be known as the GPS company. So connecting the dots with Esri here a little bit. So as we heard this morning, people that are working in ArcGIS are working with all different types of data, and they're doing the analysis so that ultimately a decision can be made. So if you want to have a good decision, you need to have a strong analysis, and if you want to have a strong analysis, you need to have good, accurate, and reliable data. And especially when there's a spatial component, that's where Trimble comes in with a range of geospatial hardware and software solutions, everything from total stations to land-based scanners, mobile mapping systems, GPS or GNSS, of course. We have UAVs, we have the handhelds that people in here might be more familiar with. And then, of course, we have a very strong suite of software behind all of those different data collection technologies. And I think I really like this quote. It captures a lot of what I just described. I'm just going to read it quickly. Spatial data is becoming more ubiquitous across both our professional and personal lives. If we are aware or not, spatial context is already a fundamental element in most decision making. And I think that really captures for me the essence of the theme for the conference, the science of where. And it's sort of why, for me, it's why we're all sitting here today. So a lot of years ago within Trimble, there was a vision. We wanted to provide centimetre accuracy for everywhere around the world for everyone. And over the years, we've made a lot of progress in allowing our customers to achieve centimetre accuracy everywhere with the evolution of GNSS technologies like RTK, VRS, and more recently RTX, to name a few, or to use a few acronyms. But we haven't made much progress in allowing that technology to get to everyone. It's still in the domain of the surveying and mapping specialists. To provide the capability to measure with centimetre accuracy for everyone, we had to do a few things. We have to make a complex technology simple. We have to make it affordable. We have to make it convenient to purchase and easy to use and to understand. As we're trying to push past the specialist or the groups of specialists, the surveyors and the mapping specialists that know what a coordinate system is, things like that. We push down the chain, if you use the images I've got there, to reach the folks that are doing landscaping or fencing or pipe laying, applications like that, where there is a need for accuracy, but perhaps not the skill set to really achieve the accuracy in the right way. So with Trimble Catalyst, this is what we've now done. So what is Catalyst? I've heard it described a few different ways. What Catalyst is it's a new GNSS solution from Trimble, but it's implemented in software. That software sits on your mobile device and provides accuracy on demand for the application that you're using on your device. So be it collector or something else, it's providing a new level or a better level of accuracy for that device than it can achieve with the internal GPS. And we're offering it as a subscription model as well. And it really does represent a new era of geospatial solutions for Trimble. So what do you need? It's very, very simple. You've already got a device. At the moment, you need an Android device, but we know that a lot of people carry iPhones as well. So you've already got your device. You've already got the app that's running on the device, for example, Collector. You need to download a small utility app from Trimble to manage the subscription, but you've got your device, you've got your app like Collector. You put that together with a Trimble DA1 antenna, and then you need a subscription to the service. So in this example, I've got Collector listed as the software, but it can, we offer an SDK, or we have an SDK ready to go for other software packages. And even if there's not integration within the software, using that Trimble Mobile Manager utility, you can push the position that you're getting from the Catalyst engine to the location services layer of the Android phone. So in that sense, any application that runs on the phone, even something like Google Maps, can take advantage of the accuracy that Trimble Catalyst can deliver. In terms of the service, you just pick your accuracy. All of the magic happens on the back end. So this is part of us trying to make it very easy for customers to achieve the accuracy. They don't have to worry about the correction type, the correction mechanism, where they are in relation to a base station or a network, any of that sort of stuff. We take care of all of that on the back end now. All the customer needs to worry about is the accuracy that they want to achieve. And there are 4 different accuracy levels: meter, sub-meter, decimeter, and what we call precision, which is sort of RTK-ish, 1 to 2 centimeters. And we offer the subscription on a monthly basis. But we're flexible there as well. So if there's a project, for example, that runs over a different period of time, then we can offer a project or a subscription for a project duration as well. So why Catalyst? So for customers that perhaps don't reach a traditional GNSS solution like an R2 or an R10 or something of that nature, perhaps for financial reasons, perhaps for technical reasons because they don't have the skill set to really get the most out of it. Why is Catalyst a good solution for those type of customers? There are 3 reasons. I'm not going to go through them all. I'm try to save some time. I know it's late, but it comes down to being easy to use and cost effective are the 2 main reasons, and I've got some sub-bullet points there as well. Just before we see a demo of the technology, I've got a couple of 3 different use cases that I wanted to quickly go through, or sample use cases. These are real customers that are using the Catalyst technology today. The first one is in New Zealand. It's an event management company called Mystery Creek. So they are mapping the event locations and facilities. So it's sort of basic mapping and asset management workflows. They've subscribed to the precision accuracy level. And the most interesting thing is why they chose Catalyst versus one of the more traditional solutions that Trimble and other companies offer. They chose Catalyst because it's more cost, or their surveying or their mapping work, I should say, is seasonal in nature. They have events through the summer, through the winter, they do all their maintenance and things like that. So their need for the system or for the mapping capability is very seasonal. So a subscription model suits their needs very well. And like you'll see across all of these customers, the ease of use is a factor as well, because none of these customers fall into the traditional surveying and mapping bucket. The second customer is out of Arizona in the US. It's a landscaping company that's working primarily with golf courses. So they've got a subscription to the meter level accuracy. And why Catalyst for these guys? Again, seasonal in nature. They have a maintenance season, and it lets them easily scale up and down the workforce within their operating expenses for the maintenance season. So with a subscription model, there's no capital investment up front, and it allows organizations to scale up and down within their operating expenses, which is a need or a trend that we're seeing in the market more and more. And again, it's a non-specialist or non-geospatial specialist company, so the ease of use for that workforce was a big factor as well. And last but not least is a farm infrastructure company out of the UK. So these guys are managing things like tracks and fences and irrigation, so it's sort of an asset management situation. So these guys have got a decimeter level subscription. And why is Catalyst a good fit for these guys? It's because being new to GIS methodologies, this provided a very low barrier to entry, both from a financial perspective, because there's no capital investment, and also from a learning curve perspective, because it's very easy to use. You just plug it into your phone and then choose the level of accuracy for your subscription and go. And yet again, the ease of use is a factor. So just looping back, Trimble offers a very wide range of geospatial technologies that connect the physical and digital worlds, and when the data that's going into the ArcGIS platform, to get the best analysis and ultimately the best decision, when you need accurate, reliable data, that's where some of these solutions can come in. So that's all of the content that I had. I thank you very much. If you've got any questions, then please come over to the Trimble booth tomorrow. We've got a large group of people that are happy to answer your questions about this technology or any of the others. But right now, I'll throw it over so you can see the demo. Thank you very much.
Can I request Mr. Ashit Makija to be on the stage? Jonathan, can you just wait for a second? Thank you, Trimble, and thank you, Jonathan. So we'll have a very small demo of using the Catalyst, of how we can be getting Catalyst is getting integrated into our collector app, and you can see how precise the results are getting in. So we are doing a small plot mapping, and you can see how Catalyst helps in correcting the results what we are receiving in. So Ajit, please.
Thank you, Krishna. Okay, so here the scenario is land parcel or tax parcel data collection. So which will be helpful for local bodies to increase the revenue. So currently, I have a project here. For that, I'm using Workforce for ArcGIS application. So from this application, I can assign my crew a task, so which they have to follow. They have to go into the field and they have to collect the data. So my field crew is currently in the field. So let's have a video call with them quickly. So you can see the noise. They are actually here in the Surajmal market. Just a second, let me connect once. Okay, fine. We have some issues. Okay. So you can see the noise. They are currently into the field. So they are using this Trimble catalyzed antenna. And we'll be assigning first a task to them. So using this task assignment button. So task will be collection of land parcel data. And we're going to assign it to my colleague Prashant. You can see his location here. So with the help of this application, you can track your field crew also. Then once you assign, you have to define the priority. So I'm going to set it to critical. I'm going to put the due date to suppose 14th. And suppose they have to complete it by 12:15 noon. And we can define the, first of all, location. So I want to do it to near his location only. Once it is set, I can go ahead and create the assignment like this. Yes. So once the assignment is created, so let me just talk to them over the phone. Hi, Prashant. Sharat?
Yeah, Ajit, yeah, they have initiated the task.
Okay.
Now they have started collecting the data.
Okay, please, I have assigned the location. You can.
They have done the parcel collection.
Okay, sure.
And now they have been capturing the photo and they are filling out the attributes for that.
Okay, thank you, Sharat. So you can check the results in web app here. Yes, it's done. So let me show you the time and all the details here. So you can check here, and if they have attached photo also. So can you attach photo?
Yeah, they are attaching the photo.
Sure.
Right now they have been going across the parcel for collection of its bound.
Okay. So using the antenna, what they're doing, they don't have to manually collect the point or the parcel. What they have to do is just they have to walk using that antenna along the parcel. So automatically the collector streaming services will collect that parcel, and then you can save and fill the attributes and then attach your data, the photograph basically.
Yeah, the update has been sent.
Okay, so update tag is sent. So let's go and check it then. Yeah. So this was the parcel they collected here, and we have the attachment also. Yes. So we know.
They are updating the workforce.
Okay. Now in the workforce, let's see then. So this was the same location. So let me show you how the app works in the background. So this is the collector for ArcGIS for Windows, first of all. And we have the same parcels here. And this was the updated parcel from the field. So I can go ahead and start this plus button here, and I can choose what do you want to collect. So so we can either go with the catalyst service, or you can manually put you can collect the survey or the parcel. And once you're done, you can go ahead and finish the tasks here. So let's go back to the results once again. So this was the parcel that was collected, and with this photograph here. So that's all. Thank you very much.